Okay, there you go. So good afternoon ulit, Josh, no? And welcome to another session ng Organic Chem. If I'm not mistaken, this is our fourth or fifth session for Organic Chem. Or baka six na ito. Hopefully, we'll finish everything today. But last meeting, we ended up with um, a new chapter, no? We started already a new chapter, which is, or a new part ng chapter 1, which is part 2, acids and bases. Like what I mentioned, this is not new to you because we've mentioned or we've discussed already acids and bases in Gen Chem, then eventually in Anachem, especially yung mga Ka, pKa, etc. No? So, what we want to do here in this chapter is to make you familiarize with organic acids and bases. That's the reason why majority ng examples dito ay puro organic acids and bases lang. No? So that you'll be more comfortable when dealing with organic acids and bases, especially when they will participate now in chemical reactions. Okay? So, and then, ang susunod na tanong dito, ang organic compounds kasi, Josh, like what I mentioned, di ba, na, alam mo na to kasi pinag-drawing kita ng mga organic compounds. You can have a lot of organic compounds, no? So therefore, it's a practical skill for us to know, no, which among the compounds will be the most acidic or most basic, etc. No? So, the trend, no, for acid strength is really important as an organic skill. So, with this, paano ba natin malalaman, no, yung factors affecting acidity of an organic compound? So, by the way, Josh, please remember, Josh, kapag tumitingin ka ng acidity, ano ang kailangan mong tignan na atom? Sige nga. If you're looking for the acidity, what atom is involved in acidity?
Hydrogen.
Again?
Hydrogen.
Very good. Proton, no? Kasi nga, ito yung nandun sa proton, sa broadside Lowry definition, no? If it's an acid, if a substance is an acid, then it's a proton donor. If it's a base, it's a proton acceptor. So last meeting, I already laid out these three factors na affecting acidity of organic compounds. The first one is element effects. So ang shortcut dito sa elements effects, Josh, saang atom ba, no? This hydrogen, this acidic hydrogen, is attached to what element, no? So, susunod will be inductive effects, which will be our discussion for today, and then eventually resonance effects. So, let's just review yung sa element effects, ha? So, please remember din, Josh, no? The more stable the conjugate base, the more acidic the acid. And that's the reason why we have these three factors as well. So, ngayon, tignan natin, no? Which one is more acidic? Water or methane? So, by analyzing, Josh, no? Your hydrogen is attached to oxygen. And in methane, your hydrogen is attached to carbon. Which one is more electronegative?
Oxygen.
Of course, oxygen. So, yun lang yung shortcut natin dito, Josh. If the hydrogen is attached directly to an electronegative element, that hydrogen is acidic. No? So, it's easier for us to compare compounds. So, since oxygen is much more, ito talaga yung reasoning din, no? Since oxygen is much more electronegative than carbon, it more readily accepts a negative charge. So, when water is acting as an acid, then the water loses a proton or hydrogen atom, you'll now form this conjugate base, OH minus. And then the negative charge is sitting atop your oxygen atom. And we know that hydroxide is a very stable conjugate base. In fact, 'di ba, sa analytical chemistry, ano nga ang pinaka-strongest base in water? Na-mention natin 'yan. What is the strongest base in water?
OH.
Oh, yes, OH minus. And then the strongest acid in water is of course H3O plus. So if you will recall, H3O plus and OH minus are products of your auto-ionization of water. No, so ngayon that rule, Josh, applies to all compounds. So when you do the autoionization of other compounds that will be their strongest acids and bases in their respective medium. Okay? So, yeah, ito na yung parang pinakaano natin, no? Question, Josh. A lower pKa means what? More acidic, less acidic? Lower pKa.
So, kung yung PKA is, ay yung KA, so kung mataas yung KA, then PKA is lower.
Okay, correct?
So, kung gano'n PKA lower means, more acidic.
Okay, good. Kapag ang Ka ay sobrang liit, Ka tama, di ba? Ang Ka ay sobrang liit, ah, what will happen? It's a weaker acid. So therefore, so lalaki yung pKa mo. Kasi baliktad yan sila no, ng trend. So correct, if your Ka is really large, it means you're favoring the formation of the products. That's the reason why its pKa value will be smaller. That's the reason why then, among these given atoms, no, sino ang pinaka-acidic? Yung hydrogen attached to your
Fluorine.
fluorine. So, yeah, we can have this trend, no, na from left going to right, nag increase yung acidity kung saan naka-attach yung hydrogen atom. Okay? However, paano naman from top to bottom, no? Which one is more acidic? Yung hydrogen na naka-attach sa smaller atom or hydrogen na naka-attach sa larger atom?
And then
Hmm.
naka-attach sa, smaller atom po.
Sa smaller atom, why?
Hmm,
Because
ah,
the smaller atom can easily donate
mas,
hydrogen.
mas malapit po yung, ano, nung,
Hydrogen
mas
sa smaller atom.
po sa smaller atom.
However, pag mas malapit siya sa smaller atom, let's say smaller anion, Josh, eh di lalakas yung attraction nila, mas
Okay.
mahirap ibitawan si hydrogen, right?
Hmm,
Mhm.
tama po.
Tama yung sinabi ko. So, ngayon, ano ang
Tama
trend
po.
talaga?
Larger atom is, more something, more acidic.
More acidic. Okay? So, ngayon na, ang trend, Josh, is from top to bottom, what happens to your atomic or ionic size? Increase, decrease. Top to
Larger,
bottom, periodic table.
larger atom.
Yeah, larger atom. So, nag-i-increase siya. So, ang acidity, nag-i-increase, nag-i-decrease from top to bottom.
Increase po. Dapat.
Nag-i-increase din. Okay?
So, kung ano
Because
po
you
pala,
have, hmm,
oh, kung yung metalloid na po pala po si, kumbaga theoretically, tennessine po is a metalloid. Ano po
okay.
may, will it affect what the acidity of HTS?
I think so. Dapat maano niya yung ano. So, supposed to be masusurpass niya even yung acidity ni astatine. Pero that's ano, no? A
Pero
very acidic metalloid.
naging naging metalloid na po siya yung si
Oo nga eh.
But,
To be honest, I don't have any idea. Pero pagsusundan natin yung trends because the trends must be ano, no? Are there for us to predict the properties of your element. So if that is the case, tennessine will be an acidic metalloid. That's my ano, no, my theory or my um most probable answer. So, yeah. Ano yun? Kung ma-observe natin yung tennessine for a longer time and magamit natin siya as a compound itself, no? So, yeah, because tennessine is larger in size compared to astatine. Okay, yeah, that's the trend, no? We can see here increasing in size, increasing at acidity. So, we're
ah,
done with this one as well, yes?
yung pinaka-ano po, yung pinaka-strongest na organic acid po, is it aromatic?
Yeah, I think may aromaticity yon yung strongest
Ah,
acid.
Kala ko po
Organic
kala
sa
ko po
organic ito. Usually
kala
may
ko po
mga, in a general sense yung stronger acids in organic compounds, usually they have aromatics, no? Pero dapat may acidic form din or may acidic group siya. Later you'll see, no, yung isang example ko na ano talaga siya, very acidic na. organic compound. It's a usual compound in organic chemistry if you want a strong acid. So we're also done with this one, no? Yung 1, 2, and even both items, we identified which one is more acidic, no? Or sa anong compound yung mas acidic? Wait lang, just siya. Very fast. Okay, going back. So we now move on with the second, ano no, with our second factor. The second factor is about inductive effects. So medyo bago sa iyo yung term na ito, no? Kaya listen very well ha. Pay attention dito, Josh, because we'll end naman around exactly 5:15 so that you can prepare for your next activity. So when you say inductive effect, Josh, ganito siya. It's the pull of your electron density through a sigma bond or through sigma bonds caused by electronegativity difference of atoms. It's like playing tug of war, no? So the more electronegative atoms stabilize the region or regions of high electron density by an electron withdrawing inductive effect. Yan, naririnig mo na yung term na electron withdrawing. Okay? So, ang shortcut dito, Josh, yung electron withdrawing atoms, sila yung mga highly electronegative elements mo. So, sino-sino nga ulit yan, yung mga highly electronegative elements?
Yung ano nga po, si nitrogen, oxygen, chlorine po.
Okay, nitrogen, oxygen, fluorine, and chlorine. Okay? So, limit lang natin doon. Pero actually ha, sa organic compounds or sa our organic chemistry, pwede nating i-extend yung pagiging electronegative na atoms kila sulfur at saka kay phosphorus and even bromine and iodine. No? So, your halides will be electronegative elements as well as phosphorus and sulfur. So the more electronegative the atom and the closer it is to the site of the negative charge, the greater the effect. So it means just ganito siya. The acidity of Ha increases with the presence of electron withdrawing groups in your alkyl group, no? Or yung kung saan naka-attach si hydrogen. So parang ang nangyayari kasi hinihila ng mga electronegative elements yung electrons, no, towards themselves because they're electronegative nga. Therefore, it's easier for us to remove hydrogen. Parang ganito siya. Let's say ito yung Ha mo, no? So, di ba, kapag electronegative si A, Josh, what will happen to your bond? This is an
Yung,
electronegative element.
ano po yung,
The electrons are leaning towards where?
towards the A.
Leaning towards, again,
A.
A. So, therefore, what will happen to your charge of A? Covalent bond yan. Pero magkakaroon siya ng anong
Negative
charge
po.
ng A? Partially negative. Pero ito ngayon yung scenario, Josh. So, yung H mo dito, this is your acidic hydrogen, no? So, you always look ha, kapag nagko-compare ka ng compounds, Josh, you always look dun sa acidic hydrogen or possible acidic hydrogen. Ngayon, ito yung susunod na scenario, Josh. Let's say si H ay naka-attach kay C, tapos naka-attach si C ay naka-attach kay C ulit. Versus si H ay naka-attach kay C, then naka-attach kay chlorine. Okay. May malaki bang difference sa dalawa? Of course, there's a major difference between the two. Which
Covalent.
one, which hydrogen will be more acidic? Tingin mo, Josh?
E,
One or two?
wait lang po. So, 2. Kasi mas, mapapul sa kanya yung ano eh, mapapul. So, kumbaga po sa C, okay, mapapul niya. So, mapapul ulit mo ng isang C. Or,
Pero
hindi pa,
parehas
yes,
carbon ha. Please take note, your acidic hydrogen atom, Josh, is attached to carbon, which are the same for both 1 and 2, right?
Opo.
So, why is your answer number 2? Sige, go ahead. Tama na yung explanation mo.
Mapo-pull ni CLs yung whatever na pull ni carbon. So,
Correct.
nagwo-form.
Oo. Yan yung tinatawag mong inductive effect. When you say inductive effect, it's not actually a direct interaction to your acidic hydrogen. Pero ang nangyayari kasi, since chlorine is a highly electronegative na atom, you're pulling electrons towards chlorine. So, ang nangyayari, dito pinaka-polar ang bond, Josh, no? Carbon and chlorine, dyan pinaka-polar ang bond because you'll have a partial negative charge kay chlorine. And what can you say about sa carbon, Josh? Anong charge niya? For number 2. Number 2 is correct. You're correct. 2 ang mas acidic dito.
Opo, mas
What will
maraming
be the charge of carbon? Partial?
partial negative pa rin.
Partial negative pa rin?
Or partial positive naman. I
Partial
don't know.
positive siya. However, kung partial positive to, anong gagawin ni carbon dito sa band na to? Hahatakin niya rin yung electrons mas papunta sa kanya. Yan yung tinatawag mong inductive effect. Kasi di ba, nagpa-partial positive si carbon. Eh si carbon mo, it's also bonded pa. It's still bonded with your hydrogen. So therefore, this bond between carbon and hydrogen will now be affected. So imaginein mo, no, si chlorine, 2 bonds away siya kay hydrogen. Di ba tama? 2 bonds away siya sa hydrogen. Kasi chlorine, bond muna kay carbon, si carbon bond sa hydrogen. So 2 bonds away siya sa hydrogen, pero si chlorine may effect pa rin sa acidity ni hydrogen, no? Like what I mentioned, it's like playing tug of war, no? So the chlorine, which is a highly electronegative element, is pulling the electrons towards itself, making your carbon electron deficient or partially positive. Then therefore, this carbon will attract the electrons in the CH bond. So ngayon ay ito, acidic ngayon to. More acidic compared to your typical HCC bond. No? So, ayan, let's have an example, no, para lang makita natin. So, in the example below, we have this 2,2,2 trifluoroethanol. So, paano kapag ethanol lang? So, tignan mo yung acidity ng ethanol, Josh. The pKa is 16, no? However, if we will change the 3 hydrogens, no, of your metal group, tingnan mo ha, yung CH3 mo dito, Josh, pinalitan mo ng ano? Yung 3 hydrogen mo, pinalitan mo ng what?
Mm, na
The
ano
three
po,
hydrogens were replaced
fluorine.
again?
Sinagdag po siya ng fluorine.
Okay, naging CF3 na siya, no? Since we know that fluorine is the most electronegative element, ang gagawin ng trifluoro mo, hahatakin niya yan, yung mga nandito. Parang ganito yung Josh yung mangyayari. The electrons, through inductive effect, no? Parang leading towards sila sa final carbon mo, kay CF3. So, this one will be acidic. That's the reason why we can clearly see, no, malaki yung difference, Josh. Imaginein mo ha, pinalitan mo lang yung hydrogen ni ethanol ng 3 fluorine, ang pKa, no, from 16 down to 12.4. And that's a big increase in acidity. Okay? So, the reason for the increased acidity of 2,2,2-trifluoroethanol, I've already mentioned this, is that the 3 electronegative fluorine atoms stabilize the negatively charged conjugate base, which is CH2O negative, no? So, nagiging stable ngayon yung um, conjugate base mo. Yun nga yung rule kanina, no? The stronger or the more stable your conjugate base is, the stronger acid your acid will be. Okay? So, this is the explanation. So, pag bumuo ng base, no? Conjugate base, yung dalawa, let's say sa ethanol, ito yung sa ethanol mo, no? So, no additional electronegative atom stabilize the conjugate base. So, you have your ethoxide. Ethoxide pala to, Joshua. This is an ethoxide. Pero, kapag 2,2-trifluoroethoxide, yung mga fluorine atoms mo dun sa dulong carbon, they're actually attracting your electrons, lalong-lalo na dun sa CC bonds, okay? At saka CF bonds din. Tsaka sa CO bonds, no? Making this one more stable. Kaya yung 2,2-trifluoroethoxide is a more stable conjugate base. Okay? So, tignan mo, makikita mo yung electron mapping dito. So, sa electron map or sa electrostatic map, the dark red of the oxygen atom indicates a region of high electron density. And then the oxygen atom is yellow, indicating it is less electron rich. No? So, hindi ngayon concentrated yung negative charge mo kay oxygen lang. So, pero in fact, ang oxygen, siya pa rin talaga yung negative because it's still ethoxide. Okay? However, due to the presence of CF3, the CF3 is an electron withdrawing group. Yan ha, electron withdrawing. When you say electron withdrawing, Josh, ano nga ulit meaning nito? Electron withdrawing. Group or
Ah,
element? When you say electron withdrawing group or electron withdrawing element, it what?
yan nila po, kumbaga nga parang yung CL kanina po, parang hinila niya po lalo
Good.
yung
So it attracts electrons toward itself, no, in a given bond. So inductive effects ngayon yan. Sige nga, sa part na to, Josh, ayan, bibigyan kita, siguro mga 2 minutes lang for this. So which compound in each pair is the stronger acid? Just encircle lang, Josh, ha, kung sino yung mas magiging stronger acid. Sige, I'll give you 2 minutes for this. Kaya halos magkakamukha yan sila. Let's say sa letter A, carboxylic acid. Sa letter B, parehas sa alcohol. Sa letter C and D ay carboxylic din. Sige, encircle mo kung sino yung mas magiging acidic.
bakit po hindi po na naka-latex?
Anong latest?
Mga ganun po.
Ay, oo nga, no? CL2
Or,
yan. Sige.
ano po,
Thank you for
there's
ano.
qualified question po.
Oy, ano pala ha? I already uploaded this PowerPoint sa aking G Drive. Updated na yung nasa G Drive mo.
It's a tough question.
The same lang ba yung ano? Hindi. Hindi the same.
Kala ko po the same, parang ito naman is the same. Pero,
No. It's not the same. Si longer lang yung kabila. Tama, no?
kaya nga po, mas ano ba yung longer? Yun yung question ko po. Ha?
Oo, tignan natin. Sige.
Wait, alam ko na po. Gagawa ko ng example. Ano ba yung mas ano na acidic? Propanol
Ano
or ethanol?
nangyayari kapag, tignan mo ha, kapag mas malayo, tingin mo ba yung distance ng electron withdrawing group mo or electron withdrawing element will matter? Of course,
Mm,
yes, no? Yung distance, kasi di ba, hindi naman kasi directly siya naka-attach sa hydrogen mo eh. Pero ideally dapat mas malapit siya kasi nga para mas mabilis siyang mahatak yung electrons toward itself.
So, parang kumbaga may magnet po, tapos may iron filing stone
Oo,
group
yes,
po.
'di ba habang lumalayo humihina yung magnet mo, right?
Okay, so electrostatic ano rin siya. Okay.
Correct. Electrostatic pa rin yan dahil ayan ay tingnan mo 'di ba may mga partial negative and partial positive charges kang nabubuo.
What's this abomination?
Where? No, it's not like that.
Bakit po ganito yung ano nilagay na ano? Ito po, PH2N. May
No.
structure po to that ano.
H2 H2. Oh, N2O and CH2, COOH. I-drawing mo nga yan, yung ano, give me the Lewis structure for that one, the third one. Okay, good. Lagyan mo ng charge yung nitrogen mo, tsaka yung oxygen. Okay. Oh, yung carbon mo sa COOH. No. Okay, good.
Uh,
Which one is
Thankfully.
the acidic hydrogen?
This one.
Good. Okay? Sige, mamaya natin. Wag mo nang burahin yan ha. Mamaya natin yan i-discuss. How about letter D? Letter D is really easy.
Very hard. I have no idea.
Sa ngayon yan, para at least, di ba, nasasanay ka. So, ang shortcut ganito, Josh, no? Sige, encircle mo lang. Ang shortcut is look for electron withdrawing group or electron withdrawing element. So, who are those again? Sino nga ulit yon? Inuulit-ulit ko to, Josh, ha, para ma-ingrain sa'yo yung skill. Who are your electron withdrawing groups?
Electron withdrawing.
Electron withdrawing elements?
Si Fluorine.
Okay, yung mga halogens. Hindi lang naman si chlorine. Yung mga halogens are electronegative atoms, no? So, ngayon, first and foremost, identify which one is the acidic hydrogen. So, for letter A, ito ang acidic hydrogen mo. Ito ang acidic hydrogen mo for the second compound. And which one is easier to remove? Parang ganun yung laging tanong dyan. Josh, ha? Pag acidity ang tanong, saan madaling magtanggal ng hydrogen? So, both of them have acidic hydrogen. But the question is, which hydrogen is easier to remove? No? So of course, parehas din sila may electron withdrawing, Cl and fluorine. Same din sila ng length. Anong naging tiebreaker mo dito, Josh? Why is the fluorine containing compound is more acidic than the chlorine containing compound? So for letter A, Josh, bakit kaya si fluorine-containing compound ang ano mo, ang mas acidic?
Ito ko lang.
O hindi, alam mo yan, siyempre.
I genuinely think po yung fluorine is more acidic.
Why? Because?
Negative po siya.
Because, sige, anong pwede mo i-compare between the properties of chlorine and fluorine? Fluorine is more what?
More electronegative po si fluorine.
Very good. So, yun lang yun. No? Mas electronegative si fluorine, therefore, mas hahatakin niya yung electrons toward itself. So, mas magiging partially positive si hydrogen, mabilis siyang ma-remove compared to your fluorine-containing compound. The second one is letter B, no? Distance ito. No? Like what you mentioned, no? The magnet itself is a good analogy. If you will magnet and filings, iron filings, if you will place your magnet near the iron filings, it will get attracted. But if you will make your magnet farther from your uh, filings, iron filings, the attraction will lose, no? So therefore, distance matters here. So makikita kasi natin yung second compound mo, it's a longer chain. So in fact, ang acidic hydrogen mo ay nasaan, Josh? Nasa naka-attach ang acidic hydrogen? Can you encircle or underline the acidic hydrogen, Josh? Use a red marker. So, use mo yung red marker. Saan muna ang acidic hydrogen? Sabi ko sa iyo ha, ang first step mo lagi, hanapin mo yung acidic hydrogen. Second na tayo, ayan, good. So, parehas silang nasa alcohol. However, yung sa second na compound kasi, mas malayo siya. So, therefore, mas mahina na ngayon yung electron withdrawing ability niya. Then, the next one is letter C. So, kitang-kita naman si letter C, ang sagot talaga ay si N2O, no? So, si letter C, first compound is acetic acid. Okay? And if you will notice here, electron withdrawing tong N2O, no? Bakit kaya electron withdrawing sa N2O, Josh? Why is nitro group electron withdrawing, Josh?
Kasi ano nga po siya,
Disputing. Ito, nitro. So,
may
ito yung shortcut niya siya. Nitro group is an electron withdrawing group.
kasi nitrogen po is positive.
Oh, yun na ba yun? Kasi positive siya.
Mas electronegative po siya.
Kumpara kay carbon, meron pa. Kasi meron ka ding resonance sa...
Resonance.
Di ba nagre-resonance siya? So, which is another That's another concept, no, for acidity. So, tama ka naman, si nitrogen ay mas electronegative kay carbon, therefore, hahatakin niya kasi nga inductive effects to, no? But aside from that, the nitro group has resonance structure, which is our third factor, no, for, tama lahat ng sagot mo ha, these are all correct. So, yeah, this is our next topic, no? Or the next factor um, affecting the acidity of organic compounds will be resonance effects. So, when you say resonance effects, you'll have the localization of electrons. So, the localization of charge through resonance influences acidity. So, example kung sino yung mas maraming resonance structure or resonance form, Josh, siya yung mas magiging acidic. So, let's say we'll compare ethanol and acetic acid. Napakalaki ng difference nila. So, ang pKa ni ethanol ay 16, while the pKa of acetic acid is 4.8. So, why is that? So, acetic acid is actually more acidic than ethanol, even though both conjugate bases have the negative charge on the same element, oxygen. So, tama, parehas naman sila, no? Anong magiging conjugate base nito, Josh, ng ethanol? Can you dictate? What is the
Hmm,
conjugate base? Ibig sabihin
si
nun, mawawalan ng hydrogen si ethanol. CH3,
si
CH2, O,
yo,
hindi yung COO, ethanol pa lang tayo.
CH3, CH2O.
O what?
Negative.
Very good. O negative. Conjugate base eh. How about acetic acid? CH3, C, hmm. CH3C what?
Hmm, CH3, COO.
COO what?
COO negative po.
Good. COO negative din. So this one is a stronger acid. So the question here, sir, why is acetic acid stronger acid than ethanol? Because once you form the conjugate base, no, the acetate, so this is your acetate ion. Your acetate ion can exist into two resonance forms, no? So ito at saka ito. And you'll also have the resonance hybrid structure. So therefore, the more, 'di ba sabi ko sa iyo, naturo ko na to sa iyo dati pa, way back Gen Chem. If you have more resonance structures, anong mangyayari sa compound? If you can write more resonance structures, it means your compound is what? Or your chemical species is what? Mas
Ah,
maraming resonance structure.
mas maraming resonance structure. Ah, si ano po, si
Hindi, pag
acetic.
mas maraming resonance structure in general yung isang compound or isang molecule, anong masasabi mo sa stability? Less or more?
Less stable.
Kapag mas maraming resonance structure, why?
Ay, yan. Okay, good question. Kasi may nagpapalit-palit
Hmm.
pa po siya. Ah,
Ano, mas stable ba siya or hindi?
hindi po.
Why?
Ha,
Bakit hindi
teka.
siya bakit hindi siya mas stable or why is it less stable this time? So kapag kapag may resonance structure ka, ang sabi mo, hindi siya mas stable. It is actually less stable compared to your uh, without the resonance structures. Why do you think so? Sige nga, bigyan mo lang ako ng idea.
Hmm,
What's your idea on this?
mas lumilipat po kasi yung mga electrons.
So therefore, kung lumilipat ang mga electrons,
Hindi po siya
hindi mo ma
completely
hindi
stable.
magiging acidic yung hydrogen?
Naging acidic po yung hydrogen.
O ano na talaga yung mangyayari? Kapag may resonance, mas nagiging acidic o mas hindi acidic ang hydrogen? Okay. So, the rule ha, ito ngayon yung rule, Josh, actually. Kapag mas may resonance structure ka, mas nagiging acidic yung compound mo because once you loses your hydrogen, the compound itself or the molecule itself or the ion itself will become more stable. Kasi nga, may resonance structure ka. So, ang shortcut dito, Josh, the more resonance structures you have for an acid, the more stable it is. Kung kayang mag-resonance, no? So, we can clearly see here, tignan mo to, Josh. Ang gusto mo kasi dito, nakakalat yung electron density. Hindi lang siya nag stay sa isang side. So, let's say sa ethox side, no? So, the negative charge is concentrated on the single oxygen atom, so making this an ion less stable. However, if we have acetic acid, so the negative charge is localized over both oxygen atoms, making this an ion more stable. So mas stable siya ngayon. Then we can clearly see here, no? Tingnan mo yung mga may bonds. Di ba? Usually, kailan ka lang magkakaroon ng resonance? Kapag meron kang, what?
Meron something. May
When will you have resonance structures? When you have what?
delocalized
When
electrons walk.
when you have again?
When you have resonance, you have delocalized electrons.
Oh, yun nga. Kailan ka magkaka-resonance? Kasi delocalization yan ng electrons eh. Usually kapag meron kang multiple bonds. Multiple bonds. Tignan mo, sa tatlo, ethane, ethylene, and acetylene, which one is most acidic? Among the three, ethane, ethylene, and acetylene. Okay, good. So, which one is more acidic, Josh? Ethane, ethylene, or acetylene?
Si ethylene. Ay, si acetylene.
Acetylene kasi triple bond na siya, no? So, acetylene. Tsaka if you will notice, yung pKa niya, siya ang may pinakamalit na pKa. So, therefore, si acetylene ang magiging pinaka-acidic. So, kung makikita mo kasi, eto ngayon yung shortcut. Increasing percent S character, increasing stability. If you increase the S character, increasing stability din siya. If you have increasing stability, more acidic siya ngayon. Okay? So, we can clearly see here that once you form the acetylide, so ito yung acetylide that's your acetylide. The charge here, the negative charge here, it's not actually concentrated sa carbon atom lang, no? It's actually distributed. However, kapag methane, tignan mo, ayan, no? Ito yung negative. And then pag methyl, ito yung negative, no? So, your electrons are quite concentrated in one side. So, making it less acidic. Okay? So, as the lone pair of electrons is pulled closer to the nucleus, the negatively charged carbon appears less intensely red. Okay? So, ayan. Meron na naman tayong another compound. So, the CH bond in acetone, Josh, pakisagutan ito ha. Dahil wala kang space dito, pwede mo siyang ilagay sa whiteboard mo. Ha? So, the CH bond in acetone, which is CH3C2, C double bond O, idodrawing mo yung ano niyan, Lewis structure, has a pKa of 19.2. So, yan yung pKa niya. Draw two resonance structures for its conjugate base. So, dalawa ang conjugate base mo, Josh, ha? Then, explain why acetone is much more acidic than propane. If you will notice, propane has the same number of carbon atoms, 3. Ang acetone mo, 3 lang din naman yung carbon atoms niya. So, gawan mo siya ng explanation why acetone is more acidic than propane. Then for number 2, Josh, for each pair of compounds which indicated hydrogen is more acidic. So, sa A and B, no? For both A and B, sino yung mas acidic daw? Then for number 2, draw the conjugate base of each acid. So which conjugate base is uh, stronger? No? So, yan. Picturean mo muna to, Josh, or screenshot mo siya. Ayan. Bago natin, bago ko kasi sa'yo i-pa-share, no, yung, ah, bago ko sa'yo ipa-share ulit yung whiteboard mo. Go ahead. Na-screenshot mo na, Josh?
Sila mo.
Okay.
I-ano ko po.
Oh, what happened?
Sila mo.
Screenshot mo lang siya.
Ito. Sila mo. Paano kaya i-ano ko si Steve? Ano? Ano nangyari? Ah? Hindi, i-screenshot mo. Wait lang. Try ko kung masa-save. Na-charge na.
Screenshot lang.
Na-charge na.
Okay na tayo? So, sa number one, sa number
Ano ko
one,
na po.
Josh, explain why acetone is more acidic than propane. Sa number two, may two sets ka ng compounds. So, the first, letter A and letter B. So, indicate mo lang kung sino yung mas acidic. Tapos, i-drawing mo or construct the conjugate base for each acid. And which conjugate base is stronger for each pair. Okay? So, are we good, Josh? Dito? Stop share ako ha. And then I'll share now your screen or your whiteboard. Pwede ka na mag-share ng whiteboard. Ayan. Sige, go ahead. Ayan. Sagutin mo to. I'll give you at least siguro mga 5 minutes for this, no? Kasi medyo madami-daming i-drawing. Mag-aano lang din ako. Mabilis lang na CR Josh.
Nag-ano na po
Dapat,
ako ng...
dapat pagbalik ko ha, tapos na to, ha?
Delete ko na po. Uh,
Okay, Josh, you can continue answering number 2 pa. That's
Okey lang
number
po.
1, right?
Iniisip ko bakit pa siya nagiging ano, eh.
Oh,
Ah,
mas acidic. Josh, kapag acidity, Josh, natatanggalan ka ng hydrogen. Okay. Nilipat-lipat mo naman na pala. Okay, sige. Okay lang yan. Okay? Oh, may second question ka pa. Yung pair-pair. A, B. So, dalawang ano yon A, tapos per pair, identify mo which one is more acidic and drawing mo yung conjugate ng bawat acid. Tapos, which conjugate base is stronger. Yan, good. Yan, gawin mo na lang silang ah, line structure or skeletal structure. So, which one is more acidic?
mhm, okey lang po. It's a good question. Hmm.
So, parang sa sa number 2, which conjugate base is stronger? So, parang iniisip ko dito, stronger base, ibig sabihin, mas reactive siya, no? So, siyempre kapag stable ang conjugate base mo, it's not reactive, Josh. So, therefore, hindi siya stronger na base, no? Weaker base siya. Yan ang conjugate base niya. Then, okay, good. How about the other one? Okay. Okay, good. So ngayon, ang gawin mo na lang, Josh, i-box mo yung stronger acid, i-box mo yung stronger conjugate base for both pairs, for both A
Okay, so,
and B.
hmm, hmm,
So box the stronger acid. O yan, encircle yung stronger acid, then encircle the stronger conjugate base.
stronger pa na base.
Hmm. When you say stronger base, ibig sabihin, mas reactive siya. Kasi nga, dapat reactive na base siya, no? How about letter B? Okay, which one is stronger acid and stronger conjugate base?
I really don't know
The
the
pairs.
one. Yun na po.
Okay, good. So let's check. So for letter A, ganito talaga Josh yung sa acetone, no? Tama naman yung sagot mo. However, hindi naman tayo ano pa, ah, problem set. However, Josh, dapat pag mga acid base, ibig sabihin niyan, Josh, you need to start na magtanggal muna ng hydrogen. So, sa acetone mo, equivalent naman lahat ng hydrogen, di ba? CH3, CH3, then C double bond O yung nasa middle. So, if that is the case, Josh, let's say ganyan ka muna, no? Ayan. Ito ngayon yung CH3 mo. Correct? Ganito siya, Josh, di ba?
Opo.
Ayan. Then, yung strong base mo, let's say, a very strong base, kukunin niya to, no? So that this bond will be broken. Yan. Sige nga, anong product ngayon dapat, Josh? Pag ganyan yung reaction ko. Yan. Nag-arrow notation ako. Nag-curve arrow notation ako. So the strong base will get the hydrogen and then the
Ah,
bond between carbon and
malilipat.
hydrogen will be
Hindi
broken.
pa lilipat ng band.
Yes, hindi
Ibig
hindi pa siya
sabihin,
lilipat. So dapat meron kang ganitong sagot muna. Double bond O, then CH2. Nasaan ngayon ang negative? Nandito sa C. Then, tsaka ngayon magre-resonance, di ba? Pag nag-resonance yan, donate yan dito, then bigay dito. Tapos, this is another resonance structure. Actually, ito lang yan. Kasi kabilaan lang naman yan eh. Okay? So, the equivalent lang din sila. So, these two are the accepted resonance structures for the conjugate base of acetone. So, ngayon, ang tanong dito, no, meron pa pala highlight din, Josh. Medyo na ano mo na siya, no, na-anticipate mo na, pero mas advanced topic kasi. Yung propane mo, once you remove a hydrogen, you'll form this, right? Tama to. You'll form this. However, Josh, tingnan mo, ito yung tanong ko. Can you easily transfer this charge ni carbon na negative papunta dito? Di
opo.
ba? Hindi talaga. Lalo na kung
Mm,
malaking group yan. Nagkataon lang kasi, Josh, you have hydrogen here. Tignan mo, mali pa yung sagot mo. CH2 then negative. What
mm,
abomination is that? Tignan mo yung central carbon mo. How many bonds already? Sige, that carbon. Yan,
One.
CH lang siya dapat. So, tignan mo ha, kung ililipat mo yung ano mo dito, ano mangyayari dun sa central carbon mo, Josh? Sa propane, magiging
Magiging wala na po. Magiging,
isang
yun
carbon
lang
na
po.
lang, ay isang hydrogen na lang. Eh, dalawa yung hydrogen mo. Saan napunta yung isang hydrogen? Naku,
Mm,
bawal ka. Ayan yung hindi pwede sa organic. Yung pwedeng bawal ka magputol or magkabit ng bond, no? Kagad-kagad, lalo na kung mga rearrangement lang siya. Pero sa nagkataon kasi, Josh, may tinatawag kang ganyan. Pero hydride ship yun, no? Or hydrogen ship. So, I'll just check kung pwede siya sa carbanions. Kasi ang alam ko, ang hydride ship ay para sa mga carbocat ions lang. Hindi nga siya pwede. Cat ionic lang dapat siya. Mhm. Okay, that's incorrect. Tama nga.
mm.
Wala. Ito lang yan. Mawawala to. This is not possible.
Hindi po siya possible.
Yeah, tignan mo paano mo ililipat yung bond ay yung negative. Kasi nga ang question dito Josh, wala kasi siyang resonance, 'no?
Link.
So propane will okay lang 'yan kasi nga hindi naman tayo ano pa, eh, problem set. Propane, does not have any resonance structure. Therefore, acetone, yung acetone meron kasi, acetone is more acidic. Kasi mas madami yung resonance structure ni acetone. So, more resonance. Ito, walang resonance yan. So, this is your only product, no? So, next question, Josh. If this is the case, which one is more acidic ulit? Acetone or propane?
Acetone.
Okay,
Acet
acetone. So, which one will be a more stable conjugate base? Sino ang mas stable na conjugate base? Yung conjugate base from acetone or conjugate base from propane? More stable ha, I'm asking for the more stable conjugate base. Which one is the
hmm,
more stronger? More stable, more stable. I'm asking for the
si ano
stability.
ba si acetone is the more stable ano.
Okay, good. This one will be the more resonance, more stable, no? So this one will have the more stable conjugate base. So therefore, sino ang stronger base? Sino ang mas stronger na conjugate base? The
Stronger
conjugate base coming from acetone or conjugate base coming from propane?
from propane.
Very good. 'Di ba naalala mo yung rule natin sa Anakem? Ganun pa rin yan. The rule still applies here. The stronger the acid, the weaker conjugate base it will form. The weaker the acid, it will form a stronger conjugate base. Since acetone is a stronger acid compared to your propane, it will form a weaker conjugate base. Kasi nga, mas stable siya. It will not be reactive, no? Not reactive compared to your conjugate base ni propane. Since propane is a very weak acid ang propane. So if we will form a conjugate base from propane, ayan, this is a very strong base. Strong base yan ngayon. Okay, is a stronger conjugate base. Okay? Kasi nga, makukuha natin yung sa letter A and B. So this is correct. So 1, 2, 3, 4. So butylene or 1 butane. Okay, so N-butane. N-butane is your more acidic. So, ito yan. So, therefore, tama rin yung nabuo mo, no? So, therefore, ito ang magiging stronger conjugate base. However, yeah, can we transfer here? No. However, meron ka din ditong ano, no? Effects ng mga double bond tsaka triple bond. Making your um, making your compound, no? Or making your conjugate base more stable. So this is also correct. This is more acidic, but this is the more stronger conjugate base. Okay, so good. I'll be sharing now again, sharing back the slide or the presentation. Let's move on. So, susunod naman, Josh, ay actually, summary ang kasunod yata nito. Summary nung strength ng acidity. No? So, again ha, we have 3 factors, Josh ha, for acidity ng organic compounds. Kasi nga sobrang dami ng anong purpose niyan? Ang dami-daming organic compounds kasi, Josh. So, you need to have a pattern for identifying which one is a stronger acid or a stronger base. So, the first one is element effects. Increasing ang acidity from left to right if your hydrogen is attached to a more electronegative atom. That's the premise. And then increasing ang acidity from top to bottom. What is the reason again, Josh? Bakit nag-i-increase ang acidity from top to bottom?
Oh, lumalaki yung ano.
Lumalaki yung ion mo or yung naka-attach sa hydrogen. Eh ano naman kung mas malaki siya? Ano naman
Ano mo?
kung mas malaki siya? A larger volume means what? The negative
Ah,
charge will be
Nasa ano po siya, nasa farther away. Ay, yung positive charge was farther away.
Larger volume means what? The negative charge will be spread out more. 'Di ba? Siyempre, pag mas malaki yung volume mo, Josh, mas malaki yung gagalawan ng electron mo. So therefore, your negative charge will be spread out more. If your negative charge is spread out more, you will form a more stable na conjugate base. So pag mas stable na conjugate base, syempre, stronger acid yung pinanggalingan niya. That's the reason why HI is the strongest acid among the given acids there. No? So HF, HCl, HBr, tsaka HI. The second effect, no, will be, or the second factor for determination of acid strength, inductive effect. So ang shortcut nito, may presence ka ng electron withdrawing groups in your A. O kaya an electron withdrawing element in your A. And then finally, sa resonance effects, the acidity of HA increases when the conjugate base A negative is resonance stabilized. No? So, yan ngayon siya. Okay, so with that, yan. With that, no, ang tanong ko dito, Josh, sa number 1, rank the compounds in each group in order of increasing acidity. Sagutan natin to. I'll help you out sa letter A. Sa B and C, ikaw na talaga. So, rank the compounds in each group in order of increasing acidity. So, we go first with the least acidity, no? Or parang ano siya, strongest base, kumbaga, kung diyan. O Josh, tingin mo, sino ang magiging least, no? So anong ano to? Anong rule ang susundin natin? Hahanap muna tayo ng acidic hydrogen. So ito, acidic hydrogen, then acidic hydrogen. If we will see here that this hydrogen, for the first compound, it's attached to carbon. The second one, it's attached to oxygen. And then the third one, it's attached to nitrogen. So I have a question, Josh. Which one is which one is the most acidic? So, iba-iba sila ng element na pinag-attachan. Yung isa ay carbon, oxygen, then nitrogen.
Yung naka-attach kay oxygen mo.
Okay, good. So, ito ngayon yung pinaka-acidic mo. So, ito yung pinakadulo mo kasi increasing acidity eh. So, you'll place this one third. So, labanan na lang to ni first and third compound. Which one is more acidic? Propane or ethylamine? So, hahanapin mo yung acidic hydrogen. Since saan mas magaling magtanggal ng hydrogen? Kay propane or kay amine?
Kaya na po, kay propane.
Bakit?
Kay amine. Kasi si amine pala yung mas electronegative.
Correct. So, mas electronegative tong nitrogen compared to carbon. So, ito pa rin. So, ang least mo ay ito. So, dapat, ang sagot natin dito, CH3, kasi increasing eh, no? CH2, CH3. Tapos, followed by ethylamine, CH3, CH2, and H2. And then followed by, your most acidic is CH3, CH2OH. It's ethanol. How about for letter B, Josh? Sige nga, yan, yung letter B, kaya-kaya mo yan. Dalawang carboxylic acid, isang alcohol.
What is
So,
carboxylic
kaya,
acid? Most probably po
ang
wait.
weakest. Start mo muna sa weakest.
Yes, si OH na may mahaba.
Ayan, o, edi sulat natin. Okay, hindi, ako na magsusulat. Tama? Tama yan. Siya ang weakest. Kasi nga, lahat naman sila, yung acidic hydrogen mo ay nakakabit kay oxygen. However, siya alcohol lang. Yung dalawa carboxylic acid. So kitang-kita mo pa lang, yung alcohol ay less acidic than carboxylic acid. So ang susunod, sino mas less acidic? Yung second compound or the first compound? Acidic na yung parehas kasi carboxylic acid yung parehas eh. But which
CBr.
one is a lesser acid?
Hindi possible. Yung wala possible.
Okay, good. Kasi wala ka namang electron withdrawing for this one. This is just a typical propanoic acid. And then the first one will be the strongest acid. The bromoethanoic acid, CH2COOH. Okay, very good. How about letter C, Josh? Which one is the least na acidic? Hanapin mo
Ah,
muna yung mga hydrogen nila. So, ito yung acidic hydrogen.
methyl?
Ito yung acidic hydrogen. Ito, nasaan yung
Ano,
acidic hydrogen mo, Josh?
siya na po si ethylamine.
Nasaan ang acidic hydrogen mo? Hindi, check mo muna.
Yung H po sa isa. So, yung sa dulo ng amine, sa dulo ng
Okay, so ito ngayon yung magiging acidic hydrogen mo. If that is the case, which one is the least acidic? So, ibig sabihin, siya ang pinaka-basic. So,
yung ethylamine,
sure ka na dito yung alcohol ba yung strongest acid? Yes or no?
no.
Why?
Baka mas stronger pa po si amine something.
Nakadikit
Ay,
naman yung hydrogen mo sa oxygen, which is a very electronegative element.
si CH3, CH3, and po baka medyo
Tignan mo,
baka
yung hydrogen mo, saan nakakabit yan? Kay carbon lang. Hindi naman siya direct kay nitrogen. Di ba? So, which one is the most acidic muna? Yun muna na lang sagutin natin. Kasi
yung
siya
ano
na
po
yung
si
dulo eh. Hmm? Ethanol pa
ethanol.
rin. Yes, ethanol is the most acidic. So, ito ang pinaka-acidic mo. Increasing tayo. So, sino ngayon yung next na acidic? Yung first or second?
First or second. Si second.
Why? Why hydrogen attached to your methyl na naka-attach pa sa nitrogen ang mas acidic? Ibig sabihin niya, mas madali siyang tanggalin. Diba? You can easily remove there the hydrogen. Ganito ang
Pero
ano mo ha, trimethylamine yan eh. Ganyan siya.
nakadikit na, isa po nakadikit na siya sa ano, pandikit na siya sa nitrogen. Pero isa yung
Oh, which one is more acidic? Kasi ang tanong dito, sinong mas madaling tanggalin na nitrogen? Ay, na hydrogen. Siyempre, yung hydrogen attached to what?
hydrogen attached to nitrogen po.
Good. So, dapat yung first compound mo, ang mas second na acidic. So, sino ang less acidic? The less acidic is yung middle compound, si trimethylamine. In fact, ito ang pinaka-basic mo among the three. Di ba? Yeah. Ayan ngayon ang pinaka-basic mo. Then followed by CH3, CH2, NH2, ethylamine. And then followed by ethanol. Okay. Josh, napakadaming ganito sa organic ha. Yung ina-arrange-arrange mo lang. By property or what. Ito, acidity and basicity to eh. So, sige nga, pakita mo lang, encircle mo lang sa akin, Josh, which proton in each of the following drugs is the most acidic? So, to give you an idea, THC is tetrahydrocannabinol. It's the active component of marijuana. Ketoprofen is an anti-inflammatory agent. And propranolol is an antihypertensive agent. Encircle the most acidic hydrogen in each compound. So, bibilugan mo lang. Sino ang pinaka-acidic sa bawat
Parang
compound?
ibuprofen mo po yung isa. Ibuprofen.
Tignan mo, ito yung maganda sa organic compounds. Ang laki ng mga organic compounds mo, pero certain parts lang yung acidic, basic. So, the rest might not be reactive. Yun yung ano mo ha, clue mo ha. Parang as early as now, Josh, binibigyan kita ng idea na not all parts of your organic compounds will react. Only a certain portion, no, or certain functional groups. And the reaction will depend on what reagent, what reaction conditions you'll have for the reaction to proceed. Sige, go ahead. ABC. Pakibulugan, Josh, ang pinaka-acidic na hydrogen for the three compounds. So, isa lang yung bibilugan mo dyan per compound. Mag-annotate ka na lang, Josh, ha? So, letter A is tetrahydrocannabinol, letter B is ketoprofen, letter C is propranolol.
PEC po. I
Hey!
wonder what will happen if I
Gusto mo
synthesize
siyang
PEC.
i-drawing ulit? Doon na lang sa mismong ano ko, shinare ko.
Sige po. Natakot po kasi ako. Baka ay sa yung school
Okay
ko.
lang, bilugan mo lang siya. So, letter A is THC, tetrahydrocannabinol.
Okay. So,
Though yung mga components ng marijuana, Josh, may medical ano talaga sila. May medical use.
so I'm going,
May
sabihin ko po meron ako medical, I have an imaginary medical condition.
Okay, please encircle.
Ito nga po, I'm trying to decide. Ah, siguro ito. Siguro. Wait a minute. Yes, probably. Oh.
Diba parang sobrang daming hydrogen dyan. Asan dyan yung mga pinaka-acid?
I-rank ko po sila.
Asan na? Anyari? Sige, I'll check. Encircle lang the hydrogen.
Ito po yung ranking system. Meron ba pong acidity itong aromatic? Ano po?
Okay, asan na? Okay, kaya nga ang pinapano lang naman ay pinaka-acidic eh. So, correct yung mga dilaw mo. Ayan, acidic yan. This is also acidic. Walang question dito kasi carboxylic acid to eh. Ang susunod kasi dito, sa propranolol, you have two sites, no? The OH and NH. But of course, we know that OH is more acidic than NH because OH is more electronegative or oxygen is more electronegative. So, this is correct as well. Good. So ngayon, we'll proceed now with another section ng ating discussion for today. Like what I mentioned, Josh, no, I need you to be familiar with organic acids, no? So, ano ba yung mga usual acids na ginagamit sa organic chemistry or during organic reactions? The familiar acids that we have, like HCl and H2SO4, they're actually often used in organic reactions as acids talaga. However, we also have various organic acids that are commonly used. Example, we have acetic acid and paratoluene sulfonic acid or TSAOH, no? So, si Tiso. Tiso ang basa ko dito eh. So, ako gumamit na ako nito, Josh. Si paratoluene sulfonic acid. Ito. What can you say about the pKa of paratoluene sulfonic acid?
Sa low,
Really, really low. Tingnan mo yung pKa niya. Negative
not really.
7.
Sa lowest po yata, di ba, 42?
Negative
Negative
7.
40.
Hindi, may mga negative 10. Yung mga negative 10, mga ano yun, yung mga strong inorganic
Yung
acids mo.
mga fluoro
Mm.
antimonic acid.
Yeah. So it means yung paratoluene sulfonic acid, it can actually rival the acidity of inorganic compounds, no? Galing. So, asan yung acidic hydrogen mo dyan, Josh? Saan yung readily available hydrogen? Alam mo yung tipong kahit ang weak ng base mo, Josh, kung makukuha niya kagad. Ganon si toluene sulfonic acid, si TISO. Si paratoluene sulfonic acid. Ganun siya ka-important, no, na reagent sa organic chemistry kasi readily available yung hydrogen niya. Kahit may weak base ka, matatanggal na yun, no? Which one is your, acidic hydrogen there?
Acidic hydrogen, si ano po, si naka-attach kay O.
Okay. Tapos ano mapapansin mo dun sa oxygen? Naka-attach siya, bukod kay hydrogen, naka-attach siya
Equal.
sa sulfur, which is an electron withdrawing group. 'Di ba? Electron withdrawing yan eh. So this one will make your hydrogen more acidic. So partially positive. Mabilis yan ngayon ibibigay ng paratoluene sulfonic acids mo. Kaya ang question, kung mga acids madali eh. You have the inorganic acids and then you also have the carboxylic acids. However, pag bases, mas may variety sila. So common strong bases used in organic reactions are more varied in structure. To make it more organized, pwede natin sila hatiin sa tatlo, no? Number one will be the oxygen bases. Yung mga oxygen bases mo, yung mga ides, hydroxide, methoxide, ethoxide, tertbutoxide, yung mga may oxygen with a negative charge. No, that will be your oxygen bases. Then the next one, the next group of bases will be the nitrogen bases. This time, your negative charge is not sitting on oxygen. In this case, no,
Since po,
nasa nitrogen siya ngayon. Anong gagawin mo, Josh? Magsi-CR ka ba or what?
hindi po, inano ko po yung una ko. Ayun.
Yan, okay.
Mhm.
Wala kang mag-ano. Amides are usually nitrogen bases. Okay? And then finally, hydride. Kailan ka magkakaroon ng hydride? If your hydrogen is attached or bonded to what?
To some ano po, something that wants to be positive, alat.
O, kasi ang hydride ay negative eh. So, ibig sabihin naka-attach siya sa isang sobrang positive. At sino yun? Usually, mga
Metals,
very
alkaline,
active metals. Very active metals. Lithium hydride, sodium hydride, pwede rin magnesium hydride. Usually, group 1 and group 2 yan. No? Sa group 1, lahat yan. Sa group 2, yung mga nasa taas. Sila magnesium, calcium, beryllium. Yan. So, sila yung usually may hydride mo. Okay? So, those are the three. What can you say about your bases? So far, dito sa group na ito. papansin mo sa mga bases mo, Josh?
Sa mga bases, ano po sila, parang, lahat most of
May
them
common
are ano,
denominator sila, ano?
negative yung mga ano po na charge.
Correct, negative. Pero hindi naman lahat ng bases ay negative lang, eh, 'no? Either mapa-oxide ka man, nitride or hydride, lahat yan sila negative. However, strong bases yang mga yan. So, you also have strong bases have weak conjugate acids with high pKa value, usually 12, 'di ba? The weaker the acid, the stronger the conjugate base, vice versa. Okay? So, usually you'll have strong bases na net negative charge. Pero take note, Joshua, but not all negatively charged species are strong bases. Example, fluoride, chloride, bromide, and iodide. Are there strong bases?
Yes.
They are they strong bases?
Di ba po sila
Fluoride,
strong base?
chloride, bromide, and iodide.
Di ba?
Hindi. Kasi saan ba sila galing? Sa HF, sa HCl, sa HBr, and
Sila
HI.
strong.
Let's say, di ba strong acids yung mga yon? So HCl, HBr, and HI, in a general sense, no, strong acids yung mga yan. So therefore, they will produce a very weak conjugate bases. So hindi rin lahat, kaya titignan mo ng maigi, Josh, kung ano yung charge at kung ano yung composition, no? Baka naman kasi puro halide tapos nasa kanila yung negative, ginawa mong strong base yun. No. No? Dapat ang strong base mo usually nakaseat lang kay nitrogen, oxygen, and hydride. So, carbon ions, we're done with this, no? Na-introduce ko na siya sa'yo. Carbon ions, negatively charged carbon atoms, are specially strong bases. No, yung pinagawa ko sa'yo kanina previously, no? Yung, kung sino yung weak acid, siya yung nag-produce ng strong base. Makikita mo doon, mga ano yun, carbon ions yun, no? Usually, carbon ions. Carbon ions are really, really strong bases. Ngayon, pag pine-prepare ang carbon ions, Joshua, di ba negative yung charge? So, pinapartneran na, para maging salt, ipapartneran mo sila ng active metal. Usually, group 1 yan or group 2. So, katulad nito, butyl lithium. No? So, your butoxide, butoxide tuloy, hindi to butoxide. Butyl carbon ion is neutralized, no, by the positive charge of lithium plus. So kapag mga alkyl group, no, na naka-negative charge, very strong bases ang mga yan. We also have bases na neutral. So amines, in general, they are neutral, no? They are organic bases. Such as triethylamine tsaka pyridine. Yan. So triethylamine, yan yun. Parang kamukha niya yung trimethylamine. Yun nga lang, ethyl yung nakadikit dyan. Tatlong ethyl. Pyridine, it's a benzene ring, no? Pero yung isang carbon mo, papalitan mo ng nitrogen. Ini-introduce ko pa lang sa iyo yan, Joshua. Huwag ka mag-alala, iisa-isahin natin yan. And you need to be familiar with them. No? So, yung parang kita mo na lang, isang tingin mo pa lang, okay, pili din ito. Okay? So, yung mga basic, no, like, para madali mong mag-group yung mga reactions. Ngayon, why are these two basic, no? These are basic compounds because they have a nitrogen with lone pair. So, yung lone pair mo ngayon ng nitrogen, this can readily accept proton. No? Proton acceptor tong proton donor acid. So proton acceptor base. So etong mga electron pairs na to, they can easily accept hydrogen. So therefore, pwedeng mag-act talaga sila as Bronsted-Lowry base. Take note, Joshua, we're still under the Bronsted-Lowry definition. Kasi ang next natin na topic ay Lewis acids. So, in comparison, di ba neutral bases to, Josh, no? So, can we compare the neutral bases, sir, versus the actively charged bases? Yes. So, yung mga neutral bases ay weaker in general. Because they're neutral, not negatively charged, no? Siyempre, pag negatively charged ka, you're richer in electrons. So, therefore, you can easily attract hydrogen or proton towards yourself, no? Kasi ang proton mo ay partially positive. Kaya ideally, Josh, yung mga bases mo, negative sila. Do we have question, do we have a negative positively charged base? Tingin mo, Josh, meron? In a general sense, wala dapat.
Meron po, pero konti-konti lang.
Nag-iisip nga ako eh. So parang so far sa organic chemistry, practical ayan na. Kasi for sure mag-iisip ka ng beyond the box eh. And it's okay. And it's okay for me, no? So try ko din
Meron lang po
hanapin yan.
minus. AG
Positively
minus.
charged na base,
AG
mahirap
plus.
yun. Kasi ire-repel niya yung proton. Kasi yung proton mo positive eh. No?
AG plus.
Ag plus is what?
Basic.
Ag plus is basic. Di ba Lewis acid nga siya?
Di ba
Lewis
po siya
acid.
H?
Pero ang Ag plus, it's a Lewis acid but it's not a Bronsted-Lowry acid. They are different, ha? Which is, i-highlight ko din later.
It's a Bronsted-Lowry base.
No, it's not a Bronsted-Lowry base. Yung Ag plus.
Paano?
Sa Lewis lang sila magko-fall na definition. O, ngayon, bibigyan kita ng example, ha?
Di ba po
Aspirin,
Bronsted-Lowry
yes.
siya? Accept po
Hmm?
siya ng ano? Accept po siya ng proton eh.
Yung ano?
AG plus po.
Ang Ag plus?
Hindi
Oh,
po siya nag-for.
kaya niya ba mag-accept pa ng proton? H?
Baka iba po yung naisip kong metal. May metal po na plus po. Ina-accept niya pa yung H.
H
Magka-for
plus
po.
o H negative?
H
Nako,
plus po.
magkaiba yan. O, anong metal yon?
Yung alala ko po silver, pero baka iba pa na yung isip ko.
Nako, hydrido yun. Feeling ko hydrido yun.
Hindi
Hydrido
po
is
H plus.
hydride in
Nag-form
complexation.
po siya ng 2 plus. Nag-form po siya ng 2 plus. Or something.
We'll see, we'll see. Complexation, alam mo, lagi namang may ano yan eh. Ang mga
Baka complex.
complexes, di ba napansin mo, lagi silang may exemption to the rule. Doon lalo na, kaya ang haba natin nung diniscuss yan eh. Yung complexation, tsaka coordinate compounds. Kasi, mas varied yung ano nila, mga rulings dyan. Lalo na kapag nag-ano ka na, ang diniscuss nga lang natin ay usually just yung first 3D eh. Yung first row ng metal sa D block. So, yung 3D lang. Pag nag 4D, 5D ka na, ay, mas complicated yun sila. Mas kakaiba yung mga rulings niya. Anyway, balik tayo dito. Dahil organic tayo. So, aspirin is an example of organic compound. It's one of the most well-known drugs under the category of salicylates. So, mga salicylates. So, in fact, among the salicylates, aspirin is the most well-known, no? Or the most popular one. So, it functions as an analgesic. Pag analgesic, Josh, ano siya? Anong meaning ng analgesic?
Analgesic is to analgesics.
Yes, ano?
Painkiller po, painkiller.
Yes,
I think.
correct. Relieving pain yan sila. So, usually painkillers ang mga yan. Okay?
Or
Or
fentanyl.
pain relieving. So, painkillers ang mga yan. Antipyretic is what?
Against ano po? Against fever.
Okay, good. So, anti-fever to. And then anti-inflammatory, of course, it's a anti-inflammation, no? So, agent. So, but basically, so sa ngayon ang aspirin ay ginagamit din na anti-platelet agent for prevention ng heart attacks and stroke, no? So, Josh, ang aspirin ay synthetic. Synthetic ang aspirin. So, ito yung aspirin mo. Okay? So, yung acetyl salicylic acid in neutral form, this is the structure. And then in ionic form, ito yung structure niya. So, tignan mo to acid-base lang ito. Pag naka-neutral form siya, Josh, so, yan. When protonated, it becomes neutral. So, nasaan yung acidic hydrogen mo? Nandito sa carboxylic acid part. Ayan, no? So, this carboxylic acid part, siya ang acidic hydrogen mo. Okay? I have a question, Josh. Anong meron sa stomach? Acidic? Anong nature ng stomach? Acidic or basic? Sa stomach, Josh?
Acidic.
Acidic. So
HCl.
therefore, anong ine-expect mong form ni aspirin, ionic or naka-protonated?
Aspirin, okey, tama. So, magfo-form po siya ng, yung ano nga po yung base niya.
Sa stomach, ano-anong form ni aspirin sa stomach? Kasi acidic yung stomach mo, eh. Anong form niya?
Basic po,
Ayan, nasa ano na tayo, drug development or ang mga very, very basic ng drug development.
basic po.
Oo, naka-basic form siya? Or ionic,
Ah,
dalawa lang naman eh, ionic form or neutral form pag nasa
ionic
acid,
po,
pag nasa stomach.
ionic po.
Why?
Para maano na po yung acidity.
Pag nag-ano siya, pag ionic form siya, mawawalan siya ng hydrogen, eh may base ka ba sa stomach?
Wala po,
O 'di ba, wala ka namang base sa stomach eh. So therefore,
first stage
aspirin,
lang po, first basic
yan,
lang.
aspirin is actually in neutral form and this form exists in the stomach. Kasi sa stomach natin, ang dami mong hydrogen. So therefore, protonated yung buong salicylic acid mo, no?
Ano po 'to,
Protonated yan. Hmm.
galing po 'to sa client.
Galing sa
Client po.
hmm.
Ito po, galing pa po sa client. Nakita ko po 'to, eh, yung this form exists in the intestines.
Sige. Pero ayan na, ay isa-send mo ba sa chat?
Hindi po, yung sa client po na libro, yung organic chemistry, galing pa po yun.
Mhm.
Yun, okey.
So magiging ano yan, magiging neutral form yan sa stomach. Kasi ang stomach mo ay acidic, so therefore neutral form ang mag-e-exist. Ito ngayon yung maganda diyan. Kapag neutral form kasi ang drug mo usually, Josh, they can easily pass through cell membrane. What is the reason kaya tingin mo?
Polar po si cell membrane.
Again?
Polar po si cell membrane.
Very good. Mga non-polar kasi ang cell membrane mo. So yung mga neutral at non-polar compounds, madali silang lumulusot dun sa cell membrane. So ngayon, majority ng absorption ng aspirin ay nangyayari sa stomach. No? Kung ganyan yung form. Ngayon, pag may nakalusot na aspirin sa stomach and then napasa na sa intestine, ang intestine natin ngayon ay quite basic. In fact, nasa 7.4 to 8.4 pa nga to eh. No? Yung um, possible na basicity ng intestine. So mga 7.4 to 7.6 okay na yan. No? So ngayon, dahil basic ang intestines natin, Josh, what will happen to your aspirin? Magre-react ngayon siya para magiging salicylate siya. No? So tignan mo yung carboxylic acid mo, nawalan na siya ng acidic hydrogen. So the ionic form exists in the intestines. Okay lang din naman yan sa intestine na absorb siya. Kasi marami tayong mechanism for absorption compounds no sa intestines. Okay lang siya na ionic form siya. Okay? So ionic form, it is soluble in the aqueous bloodstream through sa intestine kasi lulusot lang yan sa mga microvilli mo and then bloodstream na. Maganda yun kasi ang bloodstream natin ay water-based, no? So, and transported to tissues where it is needed. So, ngayon, ang question dito kasi, saan lang masyadong na-absorb si aspirin, no? So, sa gut ang usual na absorption. Yeah. Yung neutral form sa gut or sa stomach natin, pinakamarami na-absorb. Samantalang yung ionic form, pinakamarami siya na-absorb sa intestines. Okay, so with that, yan, another set tayo, Josh, ng problem. Draw the products formed when 2-propanol, which is CH3, 2CHOH. So, ganito yung 2-propanol mo, Josh, ha? CH3, CH, CH3, then ganito. Ayan. 2-propanol is your isopropyl alcohol. The main ingredient in rubbing alcohol. I-react mo siya either sa acid or base, no? Sodium hydride, sulfuric acid, lithium, ano to? Trimethylamine, and then uh, acetic acid. Yan. So, i-react mo yan. So, regardless kung acid or base yan, magre-react ngayon yung alcohol mo. I have a question, Josh. Which one is your reactive site for bases? For bases, sa
Kung mga
propanol, sino ang reactive sa propanol 'pag may base ka, strong base?
si propanol po, sa
Sa
propanol.
propanol, sinong atom ang reactive kapag meron kang base?
Yung H,
Very good, kasi ito ay acidic, eh. Paano naman kapag meron kang acid?
CO.
Very good, kasi meron kang lone pair dito, 'di ba? Kaya nila ngayon mag-accept ng protons. Eto ngayon yung magre-react sa mga,
Okay,
sorry,
parang I think
basic
ano na
site.
po na-infect na po kayo ng mga opioid the opioid rapid pool.
So, basic site and acidic site, 'no? So, ang galing nga nung mga alcohols, eh. Yung mga
Wala,
alcohols kaya nilang mag-react as acids and bases. Okay?
ano po pala, yung naisip
Yes.
ko, ito
Hmm.
pong amphetamine, so ano po yung methamphetamine? Meron po siya methyl somewhere?
Yes, I think ang methamphetamine. Search din
Dito po?
natin.
Ito,
Hindi ako gano'n ka-familiar sa lahat, napakadaming compounds, Josh. Methamphetamine.
methamphetamine. Ako po is there's another thing. Hindi lang po siya
Not
literally
sure.
Ayun, and methylamphetamine. So meron po siyang ano
O
po yung
compare ko, CH2, okay, CH3. Yung ano mo, yung nitrogen mo may methyl group. Kaya methamphetamine siya, Josh. Eto,
ito
magiging
pong ano,
NH, tapos ayan, ganyan.
okay.
Yan, that's methamphetamine. Very good.
So
Ang galing
kanina
mo
po
dun
pala,
kasi naano mo kagad, na-deduce mo kagad sa name, may methyl group siya. Kasi nga methamphetamine, which is correct. Correct yun.
so technically po, if I somehow for some reason, I
Mhm.
accidentally spilled folic acid and then and then I methylamphetamine, which is a legal drug. Can I accidentally, according to federal law daw po, can I
Yeah, I
accidentally
think you can you can push that case. Anyway, ganito lang ang question diyan sa number 2. Ang haba kasi ng number 2, 'no, pero try ko lang basahin. Compounds like amphetamine that contain nitrogen atoms are protonated by HCl in the gastric juices. Kasi yung stomach natin acidic, 'no, so kailangan mong i-protonate yung amphetamine. Tapos kapag lumabas na siya, made-deprotonate naman siya sa environment ng intestine kasi basic ang intestine natin to regenerate the neutral form. So, write proton transfer reactions for both of these processes. Where is amphetamine likely to be absorbed by the body? So, syempre, ang sagot dito, nasaan yung neutral form mo kung gusto mong cells kaagad yung mag-a-absorb sa kanya. Okay? Sige, paki-screenshot to Josh yung problem. Para at least, we'll end with this one. Lewis na kasi ang susunod dito eh. Yun ang
Breaking
last
Bad.
part ng ano natin, ng discussion, Lewis.
Breaking
So,
Bad po ba?
tomorrow, Josh, tapos natin to lahat. Baka mag-ano na tayo, no? Tawag
Mag-submit.
dito,
Hindi
problem
na po
set?
hindi na po dapat po.
Ayan.
The unsayable word. That's why it's only abbreviated as PS. So the word cannot be said. So the products formed in the two propanol. Okay. So if I accidentally spill my isopropyl alcohol and sulfuric acid, I will create a deadly. Nice. Okay. So NaH. Mhm. Ano ba yung propanol?
Imaginein mo, no? One-step reaction lang yan. Yung amphetamine to methamphetamine.
It comes from legal to illegal.
Ang suggestion ko, Josh, ganito. Lagyan mo ng O dot 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 then bond H para regardless kung acid or base siya, mare-react mo na. Dash, then dash H. Pakita mo yung bond between H and O. Burahin mo si H. Yan, good. Tapos, kung sodium hydride yan or base, gawin mo ng negative siya. Mawawala dapat si sodium. Tanggalin mo na si sodium. Tapos, lagyan mo ng lone pair. Tama yan, hydrogen yan. Yan. Lagyan mo ng lone pair si hydrogen. Kasi hydride siya eh. Very good. Yan. That's your... Oh, no!
Loan ano po, loan triple.
You're sneaking electrons there. I know that you just sneak an electron.
Kailangan po ng unfertilized ones. Tapos need a little more para magnetic.
Very good. Yan, sulfuric acid yan. Pasa ng H2SO4 mo. Okay, good. No.
Bigla lang it went downhill.
Good. Ang saya nito kasi natuturuan na kita mag curve arrow pushing, ganyan. So, as early as no, nag-arrow pushing ka na. Para at least pag nagbe-mechanism tayo, madali mo masusundan yung mga
Ano po,
electrons.
me arrow, schematic figure po, me arrow push.
No.
Bivalent. Okay.
Ayan, nag-i-start ka na mag-react-react. Hanggang letter D yan, ha? May letter D ka pa, Josh, ha? Sa letter D ay acetic acid yung nagre-react.
Just because I don't think it will ano po, pinalitan yung point. Why did I add another E?
Mhm. Hmm.
Word.
Oh, ganito, pag what is hydride, base or acid?
Base po.
Oh, kanino nanggagaling yung arrows? Sa base or sa acid?
Sa base.
Okay, good. Oh, from there, pupunta siya proton and then bigay kay oh, no! Hindi! Ibibigay
Sabi
niya yung
nga,
ano. So, tama yan. Tama yan. Attack kay proton. Good. Kasi partially positive yan eh. Then, bigay yan. Good. O, edi yan na. Makikita mo na ngayon. Oh, negative. Negative.
may ano po,
Yan.
may mga balls. Kaya ito pa.
Hydrogen gas. So, you form a hydrogen gas there. Nakagamit na ako niyan. Hydride reaction. Tapos may alcohol ka. Makikita mo
So, ano
talaga
po,
just
so,
bubbles.
tapos magbabubbles po siya, tapos light na po ng blue torch.
Oh, plus H2, syempre. Don't forget the byproduct. No. Sneaking
Okay.
your uh,
Dapat maganda po yun
ideas.
for mga ano po,
Sneaking your abominable ideas.
maganda po yung pag po.
No. Oh, ngayon, acid naman si sulfuric. So, sino magre-react kay propanol? Hindi,
Hmm,
arrow pushing ka muna.
si
No, hindi yan. Acid si sulfuric mo
ito
eh. So,
pala
sino?
si
Good.
oxygen
Ayan, magaganyan siya. Oh, napakalayo. Oo, saan iikot yan? Oo, oo, oo. Oh,
I think
oh, no?
malayo. Yan,
Pwede.
okay.
Sige. Okay, accepted. Arrow, good. And then, broken. Sige, tama. Broken. Broken bond. Kay O lang. No! Kay O lang. Good.
Valent po na oxygen.
So, you have an idea here. Oh, kulang yung ano mo, propanol mo. Hindi yan yung product.
Amin,
Yung
magdadagdag
oxygen
na.
here is what? How many bonds na ang oxygen mo ngayon sa
Two.
propanol? No.
So, dumagdag siya. Okay.
Good.
So natanggal na isa. Aha, negative. Positive.
Tapos 5
Hmm.
yung electrons mo dun kay oxygen. You're so bad. Sa propanol. Bura
Lima
yan.
po.
Very good. Oh, 5 yung dots mo sa propanol mo. Oh, tingnan mo yung
Ay,
original.
lima mo po. Ay, grabe. Yung mga. Ayun, okay. Isa na lang. Tapos nagdagdag ako. Yun. Yes. Okay, positive.
Para ano,
Okay.
magsiswimming ka pa.
Tapos plus. Oh,
Ay, nawawala yung isang. Oh, where's the other hydrogen? Good.
tapos may
Yan. Ano nga ulit
abomination.
tawag dyan? Kahit ano
Isoprop.
na lang yan. HSO4 negative. Ikaw talaga. Kaya nga nag-organic na tayo eh. Ay, inorganic tayo. HSO4 negative. Right? Oh, bisulfate ang product mo.
Bro, yung point tawag mo bro.
See?
HSO4 na.
It's a typical acid-base reaction, but we're now doing organic compounds or we're now using organic compounds. Really nice. Oh, sino ang base mo ngayon dyan? Oh, negative. Oh, lagay. Dalawa ang ano mo dyan. Dalawang lone pair yan, Josh. Nitrogen yan eh. Diba? Good,
Yeah.
negative. Okay. Ayan, attack. And then donate. Ang galing, no? So,
Okay.
ibig sabihin, you will produce the same na uh, you will produce the same conjugate base. Iniiba-iba mo lang yung acids or bases na ine-expose mo. You'll produce the same conjugate base or conjugate acid, no? Depending dun sa kasama niya. Kung yung sa reagent mo, kung acid ba yan
Oh,
or base.
pero this time po, magpo-produce ako na kagano'n.
Oy,
Iba na
kulang
po.
yung ano mo, product mo. Kulang yung product mo. Huwag ka mag-alala sa mga susunod na reaction na yan, Josh. Magkano yan? May multi-step yan. Magugulat ka. Minsan mga 8 step, 10 steps. No! Wala na. May kinuha siyang hydrogen eh. Di ba? May kinuha hydrogen.
Sigurado ko pag mapupunta yung hydrogen dito.
Yan. Okay na yan. Oh. Bahala ka kung saan mo gusto ilagay.
Yun na lang.
Okay. Oh, yan. Okay na yan. Mm-mm. Understood naman yan.
So parang ito ba parang si ano po ito pong molecule para siyang tao no.
Yeah. Ay, hindi, gawin mo siya mamaya. Ayan o,
Ayan
meron
na.
ulit. Sa second ano, sa letter D. Kaya mo sa letter D. Of course, carboxylic acid yung kasama.
Parang
Okay.
nakaano po parang
See?
nakasus
Oy, meron pa siya. Eh, may lone pair ka pa ah. Saan mo ilalagay yung lone pair? Hindi, dapat sa taas. Yon. O, di ba? Oh, gawan mo muna ng arrow pushing. Okay, good. Yan, attack hydrogen, then donate. Very good. No! Neighboring high oxygen
out
level.
of all of ano ba trivalent of my favorite.
Sneaking your abominable idea again. Negative.
Negative.
Okay, acetate. Ngayon, yung ano, ang shortcut ng tanong ng number 2 para hindi tayo super tagal mag-overtime. Drawing mo yung amphetamine, ionic form, tsaka ionic form and neutral form niya. Para saan ang amphetamine? Let's say, gawin mo muna HCl. So, amphetamine reacting with HCl.
Di ba po magkaka-amphetamine HCl po yun, di ba? Mismo po.
Hindi. Tignan natin.
Boring na po yung mga big ganun yun. So,
Yeah, actually, amphetamine HCl siya. Pero syempre, i-react mo na talaga mismo. Hindi, kahit gano'n na lang, oh, yung skeletal, Josh. Yung skeletal mo na. NH naman yung mahalaga dyan. Hmm, very good. Okay?
ba?
Yan mo ilalagay yung nitrogen mo. Good. Okay? Lagyan mo ng lone pair ang nitrogen. Then i-react mo siya, Josh, sa HCl. Yung HCl mo gawin mo H bond C. Yan, very good. Alam mo kagad. Hoy, no.
Ilan mo po notes per si Clark?
Oh, ewan ko sa'yo. Hindi ko dapat tinuturo yan. Inorganic yan. We're done with that.
Nakatago na po yung mga lower, okay. Mga lower shell, nakatago sila.
Gen Chem yan eh.
Siguro,
Hmm. Okay, good. Donate. Yan, magiging chloride. Where are the other, other lone pairs?
ah, pupunta ka hydrogen, yes. And then, ano ba? Yes, pupunta dito. So,
Yan.
magka-plastic.
So, ano ngayon ang ionic form niya? Okay. Yung neutral form, saan siya na-absorb, Josh? Tingin mo. Sige, sige, sige. Okay.
Gawin ko eh. Hanggang paglaban.
What's happening? Okay. Apat na ngayon yan. NH3 plus. Okay, good. That's your ionic form. Correct, tama yan. That's your ionic form. So, ang neutral form, saan siya na-absorb?
Sa intestines? Siguro
Very
naman
good.
po.
Sa intestines naman siya.
Basic siya
Sa
eh.
intestine. Hindi, ang neutral form, babalik siya sa neutral form. Sa correct. Pag nasa intestines na si amphetamine, magiging neutral ulit siya eh. Okay? So, babalik siya sa neutral form. Yan. Ay, ang ionic form mo,
Tama.
yan.
Ito po, ano
Naka-ionic
siya ng
form siya ngayon.
ano po
Gawa,
siya ng
sa stomach mo, naka-ionic form siya. No?
oo. Kaya pwede niyo po itago sa stomach niyo tapos lalabas na po ulit.
Ilalabas na. I have a question, Josh. Bakit hindi mo kayang gawing matanggalan pa ng hydrogen yung neutral form? Kunwari nasa intestine na siya. Di ba pwedeng maging acidic yung hydrogen ni nitrogen?
Okey. So, nagiging acidic po si
Sige nga,
ito
gawan mo
kapag
na let's say OH minus. Strong base yun, OH minus. I-react mo si amphetamine sa OH minus. Hindi. Si neutral. Kunwari si neutral.
oxygen.
Bali pangalawa, yan. Sige, mag-plus OH ka sa taas. Good. Yan. Yan, plus OH. Okay. Oh, may kulang ka pang lone pair sa oxygen. Sorry, masyado akong OC dyan. So, yung isang hydrogen ay kukunin niya dun sa NH2. Tama, di ba? Kasi yan ang base eh. Attack. Ayan. Then, donate. Yan. Good. Actually, yung pagitan dapat, hindi sa hydrogen, no? Okay, water. And then, yan, naging OC din siya. Okay, good. Naku, sa susunod, liliit na yan. Tignan mo, ang lalaki pa ngayon ng mga organic compounds mo. Sa susunod, ganyan ka na din magsulat. Maliliit na. Kasi
Hindi
malalaki
baka
na yung susunod. Lalo na pag mga mechanism, ang haba pa naman ng mga mechanism minsan. Josh, Diyos ko po.
parang naging symbols na lang po sila.
Mm. Ayun. Negative ngayon siya. Bakit hindi yan pwede sa katawan, tingin mo? Pwede
Ionic
yan
din naman.
talaga. Pwede yan sa lab. Pwede yan sa lab. Ionic din siya, pero cation ay anionic nga yan eh. 'Di ba? Cation yung isa anionic. Pwede yan gawin sa lab. Why do you think the ionic and negative is not that feasible sa body?
Because it does not exist.
Because the intestine will not have too much hydroxide naman. Kasi 'di ba sabi ko
Eh,
nga
kung
sa yung
nag-isip ko
intestine,
if you manage to drink a lot of sodium hydroxide po to ano,
if you
so
manage. If you manage, try to manage eating a lot of sodium hydroxide together with amphetamine or followed by amphetamine. That reaction will happen if you manage. Okay? So,
the very possibility po.
mm. So the hydroxide is not that high no in the intestines because the intestines is quite basic lang naman. 7.4 to 7.8 yata yan eh, yung pH ni intestine. So hindi enough yung basicity ni intestine to remove the hydrogen, no? Acidic hydrogen coming from your amine. Eh, your amine is basic nga in a general sense, eh, no? So hanggang neutral form and ionic form lang siya. Okay? So, yeah, that's it, no? So, that's the end of our discussion for today. Tomorrow, we'll focus on the Lewis acid-base definition ng organic compounds naman, no? So, that will be the last part of our chapter 1. So, we'll proceed with chapter 2, pero ano yun, parang i-consider natin part 3 siya ng ating chapter 1, no? Bago tayo mag problem set for organic chemistry. Para at least, pagbalik natin sa organic, alkanes na kagad tayo. So,
Opo.
yeah, we're
Ito
good.
po pala, wait lang po.
Sige, go ahead.
Papadala ko po sa chat. Ito po. Ah, ito po yung idea ko po. Ayan, pinadala ko na po siya.
Asan na yung sa chat box natin?
Opo.
Wait. Let me check. Ano na naman to?
It's a
Ano to?
organic compound.
Very possible
Opo.
yan, pero ano na yan, Josh, meron kang coordination. Tignan mo ha, ganito yung maganda sa chemistry kapag na-master mo siya. May coordination knowledge ka na, may organic knowledge ka pa. No? So, ang question mo
Tapos
dito, tignan mo, paano
matama
mo
ma-perfect.
pagdudugtungin? Tignan mo, paano mo ilalagay yung benzene ring with alkyne groups, no, surrounding it. Kasi yung alkyne groups, parang sila yung naging connector mo eh.
Opo.
Ta's may mga
Using
CF3 siya, nice. This
using
is
ano
a
po,
nice ano, molecule.
using ano
Spherical
po,
'to. Mm.
using household ingredients, please synthesize this within 5 hours.
Wow, ano siya, nanoparticle. 22 nanometer squared eh.
Wow, laki na po.
I think
Isang
ano yon.
molecule po.
No, nanoparticle yan. Maliit pa rin naman. 22 is a very small nanoparticle, Josh. Kasi ang mga usual ay manipis yan. Maliit pa rin siya na dot. Dot lang talaga yan kapag dino mo sa mga microscope. Sa TEM. Unless mag-aggregate siya. Feeling ko aggregated 'to kapag naka-solid form kasi didikit-dikit yan sila. Pero kapag naka-homogenize yan, ang feeling kong solvent nito ay non-polar dapat, 'no? Argon yung nasa kabila? Argon 'no, yung nasa labas?
Hindi po, kayo nga, I don't think so. Pero yun po yung natatakot po ako, eh, baka argon pala.
Argon yan! Ayan 'no, nasa kabila niya. Oh, may argon, argon. I think yung argon yung ano, or baka symbol lang din siya 'no, for another
Symbol
group.
po, parang ano,
Puwedeng
RG
kunwari
din.
aromatic na may aromatic compound na nandiyan nakapalibot, 'no? This is nice.
Yun,
Saang paper ito? Anong paper mo 'to nakuha?
yun 1960, something. Nasa
May mga
nasa
ganyan, synthesis of interesting organic compounds. Alam mo yung tipong wala namang possible pang gamit, pero isi-synthesize nila. Yung mga human, yung dino-drawing mo, mga human shape organic compounds, may mga nagaganyan, nagsisynthesis niyan. May mga groups na
opo,
nagsi-synthesize niyan. So, parang wala pa silang direct use, pero wala lang, gusto lang nilang i-synthesize for the sake yan ng
opo,
um, ano no, proving that the human capabilities can achieve no yung imagination natin. Kasi nililimit tayo nung synthesis sa mga knowledge natin sa organic compounds.
opo.
ACS. Nice, ACS pala ito. Ayan, o 'di ba? Yung mga synthesis ng human-like organ. Tapos tignan mo nakadikit-dikit pa sila. Polymeric pa 'to. Tapos
Polymeric
tignan
po.
mo anong use? What is the
None.
use of that? Wala lang. Ang dini-describe nila diyan usually yung synthesis part. Kasi interesting yung mga synthesis nito eh.
Opo.
Challenging kasi i-synthesize yung mga ganyan, Josh. Challenging talaga sila. So kapag nakahanap ka ng route para ma-synthesize siya, okay yun, no? That's good.
Opo.
Okay, okay, okay. Dahil magsi-swimming ka pa. Magpe-prepare ka pa for your
Opo.
swimming. Good luck sa swimming, Josh. Hopefully, you'll enjoy your swimming today.
Opo
I'll
po.
see you tomorrow, ha? We'll finish chapter 1, then we'll proceed with chapter 2, pero yung unahang part lang, mga functionalities. Okay? Para sa Friday, I think kung tapos naman na natin yun sa Friday, may problem set ka na for the whole thing. Okay? So, okay, we're good for today. I'll see you tomorrow, Josh. Thank you.
Sige po. Sige po. Bye-bye po.
See you tomorrow. I-reserve mo yung mga ano mo ha, yung mga gusto mong i-synthesize. Papagawan talaga kita niyan ng, ng
Oh,
pathway. Synthesize this compound from this. O, ikaw ngayon gagawa niyan. Binibigyan mo ako ng idea.
oh
Anyway,
no.
sige. I'll end the meeting na. See you tomorrow, Josh.
Sige po. Bye-bye po.
Mhm,
Sige po.
mhm.